Now moving to the next problem of pyramid. A pentagonal pyramid 40 mm edge of the base and axis height 70 mm is resting on one of its corner of base in the VP. The edge opposite to the corner is parallel to and 45 mm in front of the VP and parallel to HP. Draw the projections when the apex is nearer to the observer. This question was asked in December 13 for 15 marks. Since now here, instead of base edge, a corner is given in the VP. So obviously first, my assumption will be the entire base is lying on the VP with a corner on the right hand side instead of a edge. So we will start with, since the assumption is entire base lying on the VP, so I can see the true shape which is a pentagon in front view. So I have to start with above XY line. But now here, while drawing the pentagon, I need to keep the corner on right hand side and not the base edge. So first, I'll start with the base edge on the left hand side. And here the base is pentagon and not the square. Previous problems we solved for square. So here it is a pentagon. So I'll keep the base edge on the left hand side. So obviously I'll get corner on the right hand side. And since it is a pentagon, it is 40 mm. We need to keep some distance from XY line so that after marking angle of 108, it should not cut XY line. Okay. Or if you feel, you can shift the XY line below. So we'll now mark the angles 108 and we'll complete the pentagon such that I'll get a corner on right hand side. So get 108 here, then again 108 measuring on this side, so it will be 108 here, sorry 108 here. Okay, on these two lines we will mark 40 mm to get the pentagon. So we will mark the same base edge here as well as here, and we will mark two more arcs to complete the pentagon. Now to mark the center of the pentagon, we should follow that method again, marking the center of any two sides and joining with the opposite corner. So we'll mark center of any two sides. So here I'll get 20, and then for one more side I'll get 20. Okay, so I'll join by light lines again here. Okay, so this will give me the center of the base. Now joining with each corner, I can locate the slant edges for pyramid. So with center, I'll join each corner to get the slant edge. And see here, we got one corner on the right hand side because condition here is given that corner is in the VP and not the base edge. So we want corner on the right hand side instead of base edge. Okay, so now we'll give the rotations 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 4 dash, 4 dash. I will complete the corresponding top view, axis length is given as 70 mm. So from this O dash O dash, we will produce. Be careful while drawing that axis, because many times roller gets tilted. So I'll mark the axis height 70 mm starting from the XY line. I feel I should move this XY line somewhere below, because it is too closer. So I'll just move the XY line below. Now we'll draw the corresponding top view. On this line we have to measure the axis length of 70 mm, and that axis will be long dash short dash, because no slant edge will be coinciding here. So after marking this, we will project the corners up to XY line, remaining corners. So first is 2 dash 4 dash, which will give me the same projector up to XY, then 3 dash again up to XY, and then finally 1 dash to 5 dash up to XY. Okay, now I'll join with the apex to mark the slant edges. Then base, and finally 2 dash to 4 dash, this slant edge. Now we give the notation 1, 5, then O and O, 2, 4, and here it is 3. Now in next stage, the top view will be redrawn. So we need condition with the VP. So condition with the VP is given as the edge opposite to the corner is parallel to and 45 mm in front of the VP. In front of the VP means, like we had solved two problems where apex was given above the HP by some distance, but here that corner, that opposite edge means this edge, corner we considered is 3 dash. So edge opposite to the corner is 1 dash 5 dash. Now condition is given for this edge. Now here that edge is nothing but 1 5. Okay, is parallel to and 45 mm in front of the VP. Now since I can see this as a single point here, so keeping this corner still in the HP, so while redrawing this top view, I need to fix this 3 to keep that corner is still in the HP, because corner of base is in the HP, this should be satisfied throughout. So I'm keeping that 3 here only, but now that 45 mm in front of the VP, that means edge opposite to the corner means this edge 1 5. Now here in top view I am getting that as a single point 1 5. So now I need to locate this corner 1 5 45 mm in front of the VP, that means 45 mm below XY line, as we did for apex in one problem 40 mm and other problem 55 mm. So in this case we need to mark this length 3 to 1 5 such that 1 5 will be 45 mm below XY. So I'll first take a distance 45 mm below XY somewhere here, and I'll draw that locus parallel to XY, where we need to mark that point 1, 5. Okay, now I'll take this distance 3 to 1 5 and I'll cut the R to mark the base. Now here this 1 5 is automatically coming 45 mm in front of the VP. So now I'll redraw this again. So we have marked this base. Now I'll complete the remaining triangle. 3 to O. I'll get one arc, and again 1 to 5. I'll get this point is 1 to 5. So I'll cut that arc here. So we have got 1 comma 5 here, which is point in top view, but actually it is a base edge opposite to the corner, which is kept in BP. So I'll redraw this top view, satisfying that condition for that opposite base edge. Again we need to mark O and 2 and 4 in between on the base. So O, we have taken the distance from 1, 5, so we'll mark here, and then 2 and 4 again from 1, 5 here. So first we'll mark the axis O dash OO by long dash short dash, then the remaining edge again dark slant edge. Okay, I'll give the notations OO and 2 comma 4. Okay, here we are also satisfied that apex is nearer to the observer. Now we'll complete the corresponding front view in second stage. Of the projectors from each corner. Then from front view, parallel to XY projectors, 2, then 1, then 3, then 5, then 4. Locate these points. So 1 dash, 5 dash, 2 dash, 4 dash, then O, center of the base here, then apex again on the same line, O dash, and 3 will be here, 3 dash. Now we'll mark the visibility, first starting with the boundary arc, 1 to 5, 1 dash to 2 dash, 5 dash to 4 dash, then slant edges O dash to 4 dash, apex to 4 dash, then apex to 2 dash. Everything is on the boundary, so that is dark. Now we'll see the remaining two base edges, 3 dash 4 dash and 2 dash 3 dash. Okay, so 3 dash for the observer, 3 is the farthest point, so all the 3 edges starting from 3 will be marked dotted initially. If they are not lying on the boundary, then they will be kept dotted only. So I will mark first edge 3 dash 4 dash from 3 as dotted, then second base edge 3 dash 2 dash again dotted, and third is the slant edge from 3, which is 3 dash O dash, which is again a dotted, because 3 is the farthest point. Now we have covered all the base edges, and among the slant edges we have covered 1, 2 and 3. So we are left with 1 dash O dash and 5 dash O dash. So 1, 5 and O is the nearest to the observer. So those two slant edges will be dark lines. Okay, now we'll show the axis. Out of the total axis length, some is coinciding with O dash 3 dash. So we'll just show the remaining as long dash short dash. Now this completes the second stage. In third stage, we want to have we want to redraw this front view. So we need condition with the HP. Okay. Now for that, the edge opposite to the corner is parallel to and 45 mm in front of the BP. Okay. This condition is already used, and parallel to HP. Means parallel to HP is this condition is again given for edge opposite to the corner, means 1 dash 5 dash here, which was here initially opposite to the corner. So again in the next stage we need to make this edge parallel to HP, means again parallel to XY. Okay, but again draw the projection when the apex is nearer to the observer, right? So for last stage observer will look from here. So now we need to tilt this solid, this front view, such that apex will go up and this edge 1 dash 5 dash will become parallel with XY line. So we need to tilt like this, means in anti-clockwise direction. So first we'll mark the rectangle. Okay, then we'll start with a line parallel to XY. For redrawing this, so we want this edge parallel to XY. So first I'll mark this boundary of the rectangle here, so that I'll get that edge opposite to the corner 1 dash 5 dash parallel to XY, means parallel to HP. So we are tilting like this. So now we will mark two perpendiculars from each corner, this and one more. Perpendicular means here it will be exactly vertical. Now we'll mark this length, means now the shape which is horizontal we need to make it vertical, such that apex will be nearer to the observer. So we'll mark those lengths of the rectangles. Now we'll mark these points. After tilting like this, 1 dash will be here and 5 dash will be somewhere here. So we have those distances from the corner, both will be same from 1 dash as well as 5 dash. So 5 dash we have this distance which will be same as 1 dash from opposite corner. Yes. So we'll mark 5 dash here and 1 dash here. Similarly, we have distances from the same corners for 4 dash and 2 dash, which are again same. So those will be marked on the vertical perpendiculars. So here we'll get 4 dash and here we'll get 2 dash. So we'll mark those points. Here it is 5 dash, then 1 dash, 2 dash and 4 dash. Now to mark O dash and O dash, we need to mark the center line, which is this distance. So we'll mark that center first. Then we'll draw a parallel line from that along the vertical edges of the rectangle. On that line, we are going to get the apex O dash here, and on the same line, we are going to get 3 dash and O dash. So we can mark those distances from O dash apex. So for 3 dash we have this distance, so we can mark 3 dash here. Similarly for O dash we can take this distance. Okay, so we have marked 3 dash and 4 dash. So now we have marked all the points, so we will just redraw with the same visibility. So boundary arc 4 to 5, 1 dash to 5 dash, 1 dash to 2 dash, 2 dash to O dash, then O dash to 5 dash dark, O dash to 1 dash again dark, then all the edges from 3 dash are hidden, dotted. Then this edge, and small part is for axis. Okay. Now this completes the redrawing steps for front view. Okay. Now we'll complete the final top view. some of you may find this problem as difficult, but it is not that difficult. You need to just read the problem carefully and see which condition to be used in which stage. Okay. Now be careful. Last problem we did mistake while marking the apex. So here we'll first mark the apex O, then 4 dash will be on this line, 4, 5 dash, so we'll get 5 here, and 3 dash and center of the base, so 3 will be on the XY, and O, center of the base here, and this is apex, this is center of the base. Then 1 dash on this line, 1, and 2 dash on this line, 2. Okay. Now we'll mark the visibility. After marking all the points, first is boundary dark. So 3 to 4 dark, 2 to 3 dark, then 4 to 5 again on the boundary, 1 to 2 again on the boundary, and then 4 to 5 again on the boundary, 1 to 4 again on the boundary. Because if you see, if you join the slant edge O to 2, 1 is outside, so 1 to 2 is also already is also a boundary. Okay. Now after marking these many dark boundaries, we'll see the remaining edges. Now we are left with 1, 5. Out of the 5 edges, we have marked 4 edges of the base dark. Now we see for 1, 5. Since 1 dash and 5 dash is the farthest from the observer, so that will be dotted line. Now remaining slant edges, we have to join with the apex 1, 5 and O5 and O1 already marked. Now we are left with O2, O4 and O3. Okay, so for O4 and O2, since these are the outer lines visible to the observer, so O2 and O4 will be dark. They are not lying on the boundary, they are inside, but still they are dark, visible to the observer. And obviously they should be dark because they can't be dotted, because we have already marked 1 dotted line, so 2 dotted lines can't cross each other, so they should be dark again. And O3 is again nearer to the observer, O dash 3 dash, so O3 is also a dark line, because again dotted line can't cross this dotted line again. And then axis is coincident is O3, so no need to mark that. So now we will show the dimensions. First is base of the pentagon, which was given as 40 mm, and axis height 70 mm. Then the distance in front of VP for that base edge opposite to the corner was given as 45 mm in front of the VP. So that we have shown here. And then everything that HP parallel to HP, there is no need to show any angle. So this completes the solution for this problem. Okay, we have shown the axis and slant edges, everything. Just check once again whether we have left any edge. Okay, I think it's right.